All right, I'm going to go over the rest of the questions that we didn't get to in class. Even though we briefly talked about number 16 is a normal approximation to the binomial distribution, and we did not talk about that, so I'm going to skip that on the recording. Number 17 over here is the mean is 22 and the standard deviation is 2.4. Find the probability that x is between 19.7 and 25.3. So remember, whenever you have a normal distribution, you want to draw the normal curve. Draw in what's given, which means you're going to put the mean right in the middle, and then put the two values you're looking for. So 19.7 is over on the left, 25.3 is on the right, and we're trying to find the probability that x is between. So we're looking for the area between. This is the easiest type of question for the normal distribution. Finding the area between two x values, we simply use the 19.7 as our lower value, the 25.3 as our upper value, and we're going to use the normal CDF. So starting at 19.7, going up to 25.3, and a mean of 22 and a standard deviation of 2.4. So it's really important that when you're answering these type of questions that you know what you have given. So whenever you have x values given or z-scores given, that's when you use the normal CDF. If you have area or percentage or probability given, then you're going to use the inverse norm. So normal CDF, which we find under second vars, starting with an area of 19.7, ending with 25.3, a mean of 22, and a standard deviation of 2.4. We have a probability of 0.7465. Probability is always to 4 decimals. Okay, we have a couple more questions over here. Number 18 is actually pretty much identical to number 12. So I will skip number 18 on the review, but you can go over it on your own. You can see that, again, a percentage is given. Whenever you have a percentage given, check whether it's a binomial distribution. Do you have a fixed number of trials? So in this example, we have 2,500 TV shows we're looking at. Do we have two outcomes? Yes, either it is turned to eyewitness news or it's not. And is one independent from another? Yes, that's the case. And does the probability stay the same from household to household? And yes, that's correct. P is 0.36. And over here, then you're going to calculate the mu, which is n times p, and the standard deviation, which is the square root of n times p times q. Look for the minimum usual value and the maximum usual value by doing the mean minus 2 standard deviation, and over here the mean plus 2 standard deviation, and then comparing the value with those unusual value, with those usual values. And the answer you can check is no over here. So again, we'll skip that, but you can do it on your own. Okay, for number 19, it says find the area of the shaded region. The graph depicts a standard normal distribution with a mean of 0 and a standard deviation of 1. So we're looking for the area to the left of 1.13. This one would be a pretty simple one to actually use the table. So we would go to the positive side and find 1.1 in the left column, and then 0.03 on the top. Look at where those two connect, and the probability is 0.8708. So it's straightforward on the table. But we could also use the normal CDF because we have a z-score given over here. Our normal CDF, our area starts with, well, it's negative infinity. We don't know where it starts. So we simply put in a very, very negative number there. So maybe 99,999. This is where our area starts. It ends at 1.13. That's our upper bound. And then we have a mean of 0 and a standard deviation of 1. And our answer over here would be normal CDF starting with negative 99,999 or 9, ending with 1.13 and 0, 1 as our mean and standard deviation. We have a probability of 0.8708. Same we got on the table. So you can always check your answer on the table and on the calculator. Okay, we have just a couple more questions to go over. Number 20, it says on a multiple choice test with 11 questions, each question has 4 possible answers. So the probability that any one question is answered correctly is 1/4. The probability that it's wrong is 3/4. For students who guess all answers, find the mean for the number of correct answers. So over here, what kind of distribution do we have? So ask yourself the questions. Do we have a fixed number of trial? Yes, n is equal to 11. Do we have 2 outcomes? Yes, either it's correct or it's incorrect. Do we have one question independent from another? And yes, that's the case. And is the probability of success the same one? And yes, it is correct because each time we have a 1/4 or 0.25 probability. So this is a binomial distribution, which means we can easily find the mean and also the standard deviation if required. So the mean is equal to n times p, which is 11 times 1/4. So 11 times 1/4 is equal to 2.75, which is approximately 2.8. Over here, answer choice A. All right, number 21, a machine has 12 identical components which function independently. The probability that a component will fail is 0.2. The machine will stop working if more than 3 components fail. Find the probability that it will be working. So it will stop working if 4, 5, 6 or so on are failing. It will be working if we only have 0, 1, 2, or 3 components failing. Over here, is this binomial? Do we have a fixed number of trials? Yes, we do. N is equal to 12. Do we have 2 outcomes? Yes, either it functions or it doesn't function. Is one independent from another? And yes, that's the case. And the probability that any component fails is 0.2, which stays the same from component to component. So we are looking for that x, that we don't have more than 3 components fail, which is x is 0, 1, 2, or 3. So since we're starting with 0, and it's looking over here, it's the area to the left from 3, we have this probability is equal to the binomial CDF. So we don't have to do 1 minus because we're already starting at 0. It is area to the left. It is CDF because we have more than one x value. N is 12. P is 0.2. And the largest x value included over here is 3. So we have to go to binomial CDF. 12 components, 0.2 as the probability, and the largest one is 3. So our probability is 0.7946. Or in this case, it's rounded to 3 decimals, 0.795. Usually probabilities rounded to 4, but here our option has 3 decimals. All right, just 2 more questions. We are almost at the end of our review. Assume that the procedure yields a binomial distribution with a trial repeated n times. Use the binomial probability formula to find the probability of x successes given the probability p of success on a single trial. Round to 3 decimal places. Okay, so we are using the probability formula again, which is the probability that x is equal to 8 is equal to n choose x, so that's 10C8. So in how many ways can we have 8 successes out of our 10 trials, times the probability of success to the 8th power, times the probability of failure to the 2nd power. So since p is 0.5, q is also 0.5, and since we have 8 successes, we end up with 2 failures because we have a total of 10 trials. So the exponents up here always have to add up to our total sample size. So 10 choose 8, so that's 10 math probability NCR 8, that's 45, times 0.5 to the 8th power, times 0.5 to the 2nd power, and since we have the same number, we could have just multiplied times 0.5 to the 10th power. But either way will give us the right answer. The probability is 0.0439 rounded to 4 decimals, and our answer again is rounded to 3 decimals, so we're going to round it to 0.044. Which is B. Okay, very last question, number 23. A police department reports that the probabilities that 0, 1, 2, 3 burglaries will be reported in a given day are 0.5, 0.38, 0.1, and 0.02 respectively. We can put together our probability distribution. So x is our number of burglaries. P of x was given next. And these correspond over here. And then we should check, make sure this is a probability distribution. Each number is between 0 and 1. They all add up to 1. And if they are, we can find the standard deviation and also the mean by simply putting in our x values into L1, our p into L2. So go to Stat, Edit, clear out your lists, put in the random variable, put in the probabilities, and then go Stat, Calc, 1-var stats using L1, comma L2. And we have a mean of 0.64, a standard deviation of 0.74. Remember, with a probability distribution, we only have a sigma on the calculator, not a sample standard deviation. So our answer would be A. So this concludes our review, and I will see you all in class.